here and takes a while to understand. But the idea is, you know that t has to be greater than 0 on this. So the domain, so that you would say, another way to say it would just be 0, infinity, right? Is it? Yeah, go ahead. I'm in B block. Thank you very much. So it's 0 to infinity. That's nice. Excellent. So this is challenging. Any thoughts? Based on what to really focus on here. The particle is moving counterclockwise when the derivative of f of t is greater than 0. When the derivative of f of t is greater than 0. So if the derivative of f of t is greater than 0, it means that the natural log is increasing, right? Well, that's the thing. So let's look at it this way, everybody. Let's look at it this way. You see this, everybody? We had the unit circle right here, right? Let's look at it, the nice one. What was the nice one we had? X is equal to, was it sine t or cosine? What was the one we looked at first? What was the one we looked at first? You remember sine t or cosine t? Was it cosine? Let's say if we wanted it to start right there. Let's say it's cosine. Let's go to cosine, let's say cosine t, okay? So cosine t and y is equal to what? Sine t. Do you agree with? Okay, so where does that start? What's cosine of 0? 1. And what's sine of 0? So it's 1, 0, and t equals 0, right? And then what happens when you do, let's say, pi over 2? What's cosine of pi over 2? What's sine of pi over 2? So right here, we know that that's at 0, 1 when what t is equal to what? Pi over 2. So do you agree this function is going counterclockwise? Do you agree with that? So this happens, t is getting bigger, right? And what's happening here? T is getting bigger. You know it's going counterclockwise as t is getting bigger. Do you agree with that? ln t always gets bigger, right? ln t always gets bigger. It always gets bigger. Because how do you know ln t always gets bigger? Because the derivative is 1 over t, right? And t, what's the derivative of the derivative of ln is 1 over t. So this thing is always increasing. It gets slower and slower, right? But does it always increase? Yes. Does it always increase? It always increases. So therefore, you're always plugging in a larger and larger. As t gets bigger, this gets bigger. Always. And as t gets bigger, this gets bigger. Always, right? What do we know about this? As t gets bigger, it's always going what? It's always going counterclockwise. So what is this thing always doing? It's always going counterclockwise. Because ln t is always getting bigger, this thing is always going counterclockwise. Now the real question is, which you can kind of break your mind on, where does it start?
Yeah, I was just about to ask that. It has to start somewhere.
It has to start somewhere. Pick not 0, right? So you could just say verbally, this always goes counterclockwise because the value you're plugging into cosine and sine is always what? Increasing.
So would it start at like?
No, it depends on what you just, again, you have to pick a start value other than 0. So pick a start value like time equals 1. But you don't have to, it doesn't ask you where it starts, does it?
No.
It's just where is it moving counterclockwise and clockwise? Well, it's moving always clockwise. Sorry, counterclockwise. Counterclockwise. We're going to move on to the next one here. We're not spending more time on this one. You asked about this one right here, 37. Not a rhetorical question. Did you ask why x equals 10 plus t and y equals 2t? What part of the line do we get by restricting t to t less than 0? What part of the line do we get by restricting to t less than 0? Well, we could write the equation of the line if we wanted to. How do we do that? How do we write the equation of the line? What? I love that. Solve for t. What does t equal here? X minus 10. And what does t equal here? Y over 2. So you put that together and what do you get? X minus 10 is equal to? So you could say y is equal to, if you really wanted to, 2x what? Minus 10, right? 20. Oh, I can almost do basic math. Thank you. I need a chaperone. I really need a chaperone. It says, what part of the line do we get by restricting t to t less than 0? Yay. Okay. So what part of that line do we get? How do we figure that out?
I guess you plug in t equals 0.
Yes, plug in t equals 0.
Yeah.
When x of 0 is going to be 10, and what's y of 0 going to be? 0. So what part of the line are we talking about? So we have 2x minus 20. Let's just say that's it. Y equals 2x minus 20. What part of the line? What's the point?
All x values to the left of 10.
All x values to the left of what?
10.
10. When x is 0, sorry, when t is 0, x is 10. And when t is 0, y is 0. Are we good with that? So what point is this right here? What point is that? 10, 0, right? That should be 10, 0, because that's the point. So what part of the line are we talking about? Left of 10, so below. It's all the points below the x-axis. You can describe it. So look what it says. We get all the points with the line. Look at that. It just describes it explicitly right there. That's it. What part of the line do we get by restricting t to 0 to 1? Well, we know when t is 0, what's the point? 10, 0, right? What about when t is 1? What do you get? 11, 2. So how could you describe that? Well, you know that's going to be that little piece of the line, like right there. Oh, look, we get the points of the line between 10, 0 and 11, 2. Done. That's it. Can you evaluate? Yeah, you don't have to do a piecewise. Can you evaluate? That's all it's asking. That's all it's asking. And then you guys asked about this one right here, right? Describe in words the curve represented by the parametric equations. So when it says describe in words, parametric equations can be hard to describe in words. So what should you translate it into? What? Cartesian, yeah. And along, how do we go to Cartesian? Isolate what in this case? We don't need to isolate t. What can we isolate on this one? T cubed. So what's t cubed equal? X minus 3. And what's t cubed over here? 5 minus y. You put that together and what do you get? X minus 3 is equal to 5 minus y. So what does y equal? What's it mean? Negative x what? Plus 8. Nice. So here's how they describe it. It's a straight line through the point 3, 5 with slope negative 1. A linear parameterization y. Oh, look at that. It's just a linear. You can describe it in many ways. So you could describe this function with words. And there's how you could describe that function in words. The key is that t is being raised to the same power. That's kind of nice. Yeah. If t is being raised to the same power, you're going to get a line in general. It's verbally describing this function. Like this function right here, it's verbally describing there. Yeah.
I just didn't understand like the linear parameterization.
A linear parameterization of the same line. Yep.
Anything instead of t.
Mm-hmm.
Like
so this is a linear. Yes. What's the thing that changes when you make it t cubed instead of t?
It's kind
the speed. Yeah, the speed and velocity, like where it's going forward, where it's going backward. It might change direction, right? Like, it's not going to change direction in this case, but the speed. Exactly. So this parameterization is the same parameterization as this in terms of path, but in terms of speed? No, not in terms of speed. They have different speeds. Make sense?
Yeah, the derivative is different.
Okay, please put everything away. This starts at the right place?
Yeah, but then
it does start at the right. T, X, Y. 0, negative 3, and 0, right? But then you do pi over 2, for example.
Then you get
0, right?
7.
7. Is that the direction you want to go in?
No.
So what do you also have to write in? Negative 7. There it is. Ah, nice. Because you want to go counterclockwise. Ah, okay. So let's try it. One more thing. Let's say instead of plus or minus 3, I said plus or minus A. And instead of plus or minus 7, I said plus or minus B. And instead of negative 3, I said negative A. And instead of counterclockwise, I said clockwise. Write me the equation. Go. Long just did the generalization by plugging it in, so what would it be? I like that. So it would be x is equal to what? Negative cosine t, and then y would be b sine t. Why not negative? Oh, it's going clockwise now, right? Mm-hmm. Excellent. And then if you wanted to make it a Cartesian, it would be 1 over what? A squared times what? 1 over a squared x squared plus b squared y squared, right? Equals 1. Cool? Sound good?
Yeah.
Is that good? Okay, why don't you trade one person per pair and work on this one right here. So, in order for two things to collide, they have to occupy the same space at the same time. Okay, so let's say in this first one it says find k. Okay, k equals 5 is what we're dealing with, right? So, to be at the same place at the same time, you can set 4t minus 4 equal to what? 3t. The x is, for two things to occupy the same space, they have to have the same x coordinate and y coordinate. So what's the only time that happens? When t is equal to? When t is equal to 4. So the only time they have the same, hold on, we're not done yet. The only time they have the same x coordinate is when t is equal to 4, right? So in order for them to collide, 2t minus k has to equal what? T squared minus 2t minus what? 1. You don't need to do much work here because they're saying k is equal to what? 5. So that's 2t minus 5 is equal to t squared minus 2t minus 1. It says if k equals 5, do the particles ever collide? Well, we know the only time they could collide is when t equals 4. So where do we plug that in? So what do you get? You get 8 minus 5, 16 minus 8 minus 1. What do you get? 3 is equal to 7. No, that's not true. So what does that mean? They never what? They never collide. They never collide. Does that make sense, everybody? You don't always have to parameterize. Just because you have a hammer and a nail doesn't mean you always have to hit it with the same tool, okay? Find k so that the particles do collide. They do collide. What statement am I looking at right now? I'm looking at this one right here, correct? So what are you trying to do? You're trying to make that a long. Everybody, let's pay attention here for a second. So we have these two things set equal. We know the only time they potentially could intersect is when t is equal to 4. When t is equal to 4, right? So what do we plug into there? 8 minus k is equal to 16 minus 8 minus 1. So 8 minus k has to equal 7. So what does k have to be? 1. So you know they intersect when k is equal to 1, but then what do you find? You could find where they collide, right? You could figure that out, right, if you wanted to. But go on and finish this. Things you need for the equation of a line. You need a point and kids. Can you stop talking for a sec? Point and slope. Anybody have the point? What's the point? Pi comma what? I think it's negative a half. I think it's negative a half, right? Is that right? And what's the slope going to be? Anybody get the slope? Radical 3 over 3, I think, right? So what's the equation? Y minus, y plus a half equals root 3 over 3 times x minus. Yeah, I'm pretty sure that's right. Do people agree with that? That's what I got. We good? Erica agrees? Awesome. Okay, do part B. So you looked at dy dt. What was dy dt? No, what is dy dt? Tell me what dy dt is. Negative 2 sine, it's frozen. 2 sine 2t, yes. How do you know dy dt is negative? Oh, you do the derivative of y. It says y is equal to cosine 2t, so dy dt is negative 2 sine 2t. And then what did many of you do after that point? What did you do? You set it equal to 0? Did some of you do this? Did no one do that?
Wait, why is it 2?
Okay, kids, hold on. Everybody, hold on. Do you see does everybody see what I'm looking at here? Y is equal to cosine of 2t? That's y, right? So why am I doing dy dt is equal to 0? Because you want to know when it stops going up or down, right? So you're just looking at the vertical change. So you do dy dt, you have to use the chain rule. What's the derivative of cosine? Negative sign, so that 2 kicks out to the outside, right? So 0 is equal to negative 2 sine of 2t. So what do you have here? Sine of 2t is equal to what? 0. So what do you know 2t has to be equal to? Sine of what is 0? Sine of what is 0? 0, pi. Yeah, so 0, pi, what? 2 pi, etc., right? So t is going to be what? 0 or pi over 2 or? We're going to put an asterisk into something here because that just tells you when it stopped going up or down. What does this question ask you to find, though? Maximum, right? Maximum, maximum, maximum. So without taking the second derivative, because taking the second derivative is not what you need to do at this point, you need to figure out a maximum means it's rising to what? To falling, right? Rising to falling. So there's a second derivative test. There's also a what? First derivative test. So what could you write here? You have all these things. 0, pi over 2, comma what? Pi and 3 pi over 2, etc., right? And it wants what? T greater than, what's the smallest positive value? So greater than 0 there. So what's our first derivative? Negative 2 sine 2t, right? So what could I plug in right here? What's right in between? pi over what? Let's do pi over 4. So what's negative 2 sine of 2 times pi over 4? That's negative 2 sine of pi over 2. What sine of pi? What is sine of pi over 2? What is sine of pi over 2? So this is negative 2. So this is going to be negative into there, right? So then what's in between pi over 2 and pi over and pi? How about pi over what? Pi over 3? Anybody want to guess what that is when you... Oh, pi, excuse me. Yeah, you're absolutely right. What do you need to do there? There's a bunch, and that's not it. How about 1 quarter, 2 quarter? How about 3 pi over 4? How about 3 pi over 4? That's nice, right? 3 pi over 4. What's negative 2 sine of 3 pi over 4 times 2? So that's negative 2 sine of what? 3 pi over 2. What's 3 pi over 2? What is it? Negative 1, so this is going to be 2. So what is it here? So then what do you think the next one's going to be? And then what? So what's the smallest one where it's a maximum? Pi, because it goes up and then down. It goes up and then down. So it's pi for this one. Now, the thing I want to leave you on, we're over a minute over, but you have to C is what you really need to do on this. Remember this box from yesterday? To find the second derivative, you have to do it really carefully. First, what do you find? What's the first thing you find? That's the first thing. You do this. And you know dy dx is equal to what? dy dt over dx dt, right? And then what do you do to that thing? You take the derivative with respect to t and you put it over dx dt. Look, you're doing the second derivative of y with respect to x. Oh, there's where it comes from. Do it in that order, and then it's really straightforward. Get out of here.